So, I hope you took a good break. Let's see where all the fun begins, and even more fun. And let's see about serialization. Now, if you do not know what serialization is what it actually saves our level and loads it up. So, as far as scripting is concerned, it's basically saving some primary values and then reloading all again. Okay. Yeah, before we actually save the game objects, we're going to save them to be saving this on list. But there are some problems with serialization. We probably do not want. We might be able to save, but I'm not exactly sure. But we do not want to save anything that derives from mono behavior for a lot of reasons. And since we do not want to do that, we cannot use the scripts we've created for every part of for everything we just created. Okay, everything, the nodes, the stackable game objects, our wall. Okay, we cannot save anything from the scripts we just created. So what we have to do is go to each one. So let's start from level object. Since level object has everything in we have everything with on every game object that is on the node on our grid, it has a level game object script. Okay, and this is where this class and this class comes to play. I've explained this a bit in the previous video, in the previous part. So let's explain this once again. Okay, these are the values we're actually saving. We need to know the object ID. We need to know the position it's on the node, and we also need to know the rotation it has. Okay, we cannot save vector 3 where the rotation is a quaternion angle, but we do not want to mess with quaternions. We want to use the Euler angles. Okay, so but we cannot save the vector 3, but so we need to break it apart on the current axis and save the current axis independently. Okay, and we also need to save if this was a wall object or if this was a stackable object, and this helps us set it on different to save it on the correct list. So how we know how to create this? Now this class is not really instantiated or is not really created, but when we want to create this so that we know when we want to save this object, we're calling this function, which is a saveable level object, which is a class over here. Okay, and the first thing we are actually making is making a new instance of the saveable level object class. Okay, so saved object. Since we've created a new saveable level object, what we need to do now is assign all the info we want to take from this one over here. So we say the save object ID, the save object ID will be the object ID this level object have. Okay, same for the position X and the Z, and the wall rotation, since we cannot save vector 3s, then we say rotation X, rotation Y and the Z, we save it independently, I guess. So is wall object. If the level object is wall object, we say that the saved object is wall object. If it's stackable, then saved object is stackable too. Then return the saved object. And this is how it prepares, if you want, a new savable level object, and then in turn goes into our level save load script class and script, and it goes and populates this list with it. Okay, so we need to create one for save stackable level objects. We do not need to create a new class. It's the same as the level object, but the stackable level object, which is the plants that I'm placing over here, or the shovel, it's simply that we have a stackable object and we say it's stackable object basically. And for the prefab for our wall, we say is wall object. We say is wall object. It's not stackable, is wall object. Okay. So we need to save our nodes. Okay, whatever it happens, we will always have nodes, but our node, our base node, where is from the grid base, our base node class, go to definition. We do not want to save this class because it has a lot of stuff that we do not want to use. So what we actually want to use is save the node object that you will see that it takes from mono behavior, although I think it doesn't really have to. No, it doesn't take from mono behavior, because we're not saving this class. We're saving node object savable class. We save this class, but we need to have a way that we can actually find the nodes inside our grid, inside our level. So okay, I know where my grid is, but I do not have a way to find where all the stuff is. So if I want to take this node, I need to know that I can take this node. Okay, so the way we do that is we create a new class and we assign it on our prefab, for the floor. Okay, so what we basically, if you see here, what we are cloning every time we are creating the grid. Okay, and that is the node object class we are watching over here. So the things we only need to be concerned with right now is the position X, position Z, and the texture ID. If we want to update the node object, when we are updating the node object, we have the position X. We pass. This is when we load the new object. Okay, we call this function. So we say we pass. Let's go over it again. Okay, we have on this node object, forget everything I said. We have this object on position X, position Z, and the texture ID. These are the stuff we are saving. How we are save them? We're saving them with this class. So we create a new instance of this class, get savable. Okay, we create a new instance of this class. We assign on the new instance of the savable object class the position X and the position Z from this node, and the texture ID from this node too, and then we return the savable. And then on our level save load script, we assign it inside this list. Okay, let's go back to node object now. These two functions are used on the loading, so I'm not we're going to see it in a bit. Let's take it all because I'm getting confused too right now. And well, you know, I'm recording this all in a row. So the next thing we're going to save is save wall object savable. However, a wall object is also a level object, and it's also a wall object. So we're going to create a new class. Okay, and we're going to create the new class we're going to create is wall object savable, and we need to save pretty much both the wall object savable properties, which is on the level wall object. And if we go now, keep in mind that I'm using level editor namespace, so if you're not finding something, keep in mind on the namespaces. And as I was saying, inside our level wall object, we also have this serializable class, okay, which is the wall object savable properties. We pass the direction, we pass the corners, and we save them. Then we create a new class that contains both the savable level object class and the wall object savable properties, and then we go and say, and then we go and populate this list. Okay, so next we need public static string, save folder name, level objects. Okay, we need two functions that we're calling from the buttons, save level with a name and load level with the name, a different name. And keep in mind this is case sensitive, so if the loading button doesn't find a file that has the same name as the test level, as the name we saved, then it's going to have either error or it's going to return false. I don't really remember right now. So I think I forgot to mention on the let's go and we'll see, we might come back. So we say we need some functions when we are calling the save level. Okay, so we need to know where the save location is. We pass the level name we're going to create on the new location, and then we say the save location will be the persistent path of the application plus the slash plus the save folder name, which is this level objects, plus slash, so it's inside the level objects folder. If the directory does not exist, then create it. Okay, else retain the save location plus the level name that we're actually passing. Okay, so we create a directory and we're ready to go into our save level, our actual save level. We passed the save name. Now we need to find every level object that it's in our scene. Okay, so every game object that has the component of level object, we want it and we want to save it. Now this is the part where it's going to be a little performance intensive. Okay, and if there are a lot of game objects in the scene, then the editor is going to seem like it's stuck, but it's actually saving the level object. Okay, there are other ways you can optimize that. You can store it inside the coroutine so that you show saving, you know, a loading button or stuff like that. Okay, right now what we're going to do is just going to use find objects.type level object, and it's going to return all our game objects that have the component of level object. So basically it returns every game object we have in the scene. We clear the previous list we had, save objects list, save wall list, clear, and we probably should be clearing this list too. Okay, save stackable, if I'm not. So then we say for each level object we have inside our level object list, inside over here, inside this is an array, not a list, we check if the level object is not a wall object, then that means it's not a wall. Okay, makes sense. If the level object is not a stackable level object, then it's not a stackable level object, it's a simple level object, so add it into the savable level objects list. Okay, if it's a stackable, add it to the save stackable level objects. If it's a wall object, create a new instance of the wall object savable. Okay, assign the level object to the new instance of the wall object savable, and assign the wall object to the new instance of the wall object saveable, and we find that from the level object we use also get component level wall object get saveable. Or I think I can also do wall object, not wall object. Yeah, anyway, let's just do it this way. And okay, and it assigns the wall object. So we create a new class of this, and we assign the level object and the wall object, and we add that to the save wall list. Okay, and that ends the for loop. Now, for this controls this saves save not object list. We had it, so let's delete it from over here. No point in clearing it again. Okay, and this saves assigns everything into the correct list. Okay, this is strictly for organization purposes. And then we say we need to save the node objects. So similar to level objects, we go and take all these floors have the node object component. So we go and take all these components, all this game object. Okay, depending on how big your grid is, then the bigger the lot more node objects is going to get. So we use find objects of type similarly to what we do over here. Okay, keep that in mind if you want to do coroutines or whatever. Okay, we clear the list, and then we say for every node object inside the node objects we just found, add them on the save node object list to add. Okay, we do not have to check anything else because nodes, there will always be nodes and all nodes are the same. And then we need to create, we have the lists, we have populated them, but what we actually need to do now is create a new class of level saveable. Okay, and this what it does is what it actually is saved, and in turn comes and saves for lists. So if you want to save something else, you will add a new list over here too. Okay, level saveable, level save, new level saveable, level save. Okay, we pretty much pass the list we just populated into the save level object list. And then our level saveable class is ready to be formatted and to change the format to be turned into a binary, and then we can actually save it. Okay, the save location is the save location. Save name, string, iFormatter, new binary formatter, stream, new file stream, save location. We pass the save location, file mode create, file access write, file share none. Formatter serialize, we serialize it, stream level save, and we close the stream. And then we can add a debug log to see where was the location we actually saved it. And that is how you save stuff. Of course, saving stuff would have been useless if you couldn't load them. So we say bool load level string save name. This is what we also call from over here. Load level, return value true, string save file, save location. If the file does not exist, then the load level will return false. If it exists, we call the iFormatter once again, the stream. We create a new stream. Okay, we find the saveable, we deserialize it, and then we close we cast it as a level saveable. Okay, if you do not cast it, then Unity will not know, it will deserialize it, but it will not know what type of object it is. Okay, so we cast it and we say, this thing is a level saveable class. We close the stream, and then we pass the load level actual, we pass the save, the level saveable, and it calls this function and then it returns the value. So what this did is create a new level saveable, basically deserialized a class, an instance of this class, where we have all the previous saved game objects in here. Okay, so it calls this function, which is where we actually loading the level, so that's why it needs a level saveable. We have our list, so what we need to do now is to actually start recreating our own level. So we say for integer, we do a for loop. So for every savable level object we have inside our list, we need to say we store it so that we store the current savable level object is, because we do not want to use all this railroad over here. Okay, so we use the saved object. We need to find the node we want to place it. We use the grid base, the instance of the grid base, okay, the singleton. We find the grid and we say we want the node this saved object was placed. We know we need the position x of this saved object or inside our grid, and then for the z the same. Okay, we find the node this previous object was saved basically, and then we say game object create, instantiate. Okay, a game object, we instantiate. What prefab we need to instantiate? Go to the resource manager, to the instance of the resource manager inside this list, inside this scene, and get the object base. So basically get the prefab with the same ID as the object we have saved before. Okay, and get the prefab of the object prefab. The place where we want to place it is the place where our node is actually on the world. Okay, so it's the visualization transform.position, and we want to have the rotation we previously saved inside our level savable save level object list. Okay, and we need to cast this as a game object. So what this does, the saved object, it creates a new instance of the saved object we previously had. Okay, based on the same prefab, based on the same position, and based on the rotation we had saved inside our list. Now the only thing we need to do next is to actually update the node we place it. Okay, so the placed object will be the level object from the new game we actually created. The node placed object, the grid position Z and X will be the same as the node we place it, and the node place, the wall rotation will be the local Euler angles from the placed object we just placed. And this is what actually recreates the new level objects. The new stackable level object, the same as above. Okay, pretty much the same, but instead of searching on the resource manager, instead of searching on the get object base, instead of calling the function for get object base, we call the get stackable object base. So it searches on a different list or with the ID we pass, and it gets the prefab, it creates the prefab and pass all the other stuff we said before. Okay, now we need to update the node with the values we want to have. Okay, stackable object, get the level object, update the grid position X and Z with the same as the node, and then add the new stacked object into the node's stacked object list. And we have the stackable level object. Now our tiles. Go into all our tiles, see, get the nodes for pretty much every tile we have. Okay, and then get component node object, update node object, node and pass the previous texture ID it had, and then it will return over here and say it will come over here, update node object, saveable, and it will pass all this, and then it will call the function. Okay, it stores the stuff over here, it updates it as the name suggests, and changes the material based on the texture ID we have over here. Okay, they get the material from the level editor. Level editor is the namespace, the resource manager, the instance of the resource manager, and then get material, texture ID, current node, render, material, and then get material. Okay, and get saveable, we see all this. It just updates, takes these values basically, and returns a node object saveable. Okay, and this repaints the tiles with whatever texture it had. Now we want to create the walls. Now for integer, for every wall we have inside our list, okay, store the wall, get the grid based on the object, the positions we saved on the previous, on the wall level object, not the wall level object. Instantiate from the resource manager the wall prefab, since all the walls are the same. Put it on the correct position, which is the position the node has. Quaternion identity, since we do not care about his rotation. Level object, get a component of the level object, update its values with the stored, with the saved positions we have, with the node we actually placing it. And we need to update the properties of the level wall object. So we also need to get the component of the level wall object from the new created wall, and we say on your wall object, update the wall with the direction you have previously saved. Okay, and update corners with what you have saved inside your savable list. And this is how it recreates your walls, your tiles, your stackable level objects, and this is how you load your level. And I think we're pretty much done with this, and I hope I did not forget anything. Resource manager, we talk about this level save load. As you can see, these are a lot of stuff and a lot of work went into this. Okay, and of course I'm going to keep updating this, but I don't know if I'm going to be making a lot of videos about the new updates. But of course, this always. Now we're going to be using this stuff a lot more on videos I have planned in the future, especially the grid part. So let's see all of them in action. Okay, so we created a level editor. This is going to work on it's going to work on runtime. Okay, so your players can create your own levels, and if they actually share the file where they save it, and if somebody knows the name of the file, then you can create an interface where they load, and you can share levels between each other. Okay, so if I take this project and load it on a different PC or different project, pretty much anyway, then I can actually load the level I created in this. The level I actually created over here. Okay, and it will load just as well, and it's going to be actually pretty cool, to be honest. And then let's say I've created my cool level over here. Okay, and I click save. You will also, the debug shows us where we actually save the file over here, if you see. Okay, so I've saved this level. the next time I click play, and if I click load level, it will be right back, and this is actually pretty cool. I'm pretty happy with how this came out, to be honest. It's really cool. Now of course there are probably going to be some bugs. Okay, so don't worry about them, you can pretty much fix that. So that is all for today. Those are a lot of stuff and a lot of videos. I think we are three videos in. If you like these videos, or if you like what I do over here on this channel, then consider supporting me, because you know, all this stuff not just take time, they take a lot of time, and they take a lot of time to prepare. Okay, and all that is time that I could actually be making something else. Okay, and the ways you can support me is on patreon.com, where with $5 or more you can get access to a Google folder where I have all the scripts from the channel, and you can also buy projects from the videos I make on the channel. I have some, check the description below. I have some already. I'm going to add a lot more, and including this one. Okay, and you can actually buy, and all these ways you support me, and I can keep making cool stuff and cool videos like this. Okay, and I do not have to worry if I'm going to have money to pay my bills next month. Okay, so whichever way you can support me, then it's cool. If you can't afford the money, then the other way you can support me is, of course, by subscribing and liking the video and sharing with your friends, and you know, helping me grow the channel to something more bigger, or whatever you want to call it. Okay, so thanks for watching. We did a lot of cool stuff and a lot of difficult stuff today, but I think it pays to do some stuff that are kinda difficult to do. Okay, and some concepts that are not so easy to grasp. Okay, we cannot stay on simple stuff for a lot of the time. Then we are not progressing. If we are doing the same stuff all the time, we are not really progressing, and that is not good. So thanks for watching, and of course I'll see you next time.